Load velocity profiling. Your new competitive edge as a coach should do even better resisted sprints and speed development to get your athletes even faster. So let's dive into how to plan and execute load velocity profiles to make them as reliable as possible, as well as how to calculate everything you need to calculate in Excel. This gets turned into real life where if we have the athlete's profile, we don't have to guess. We will know exactly what load to put on the athlete to achieve a specific velocity or a certain velocity decrement. But also you will have a very thorough and detailed assessment process to evaluate your athlete's ability to sprint against load. First, we have to understand what the task actually is and what the one underpinning assumption is to make these tests as reliable as possible. So first, a load velocity profile is simply just an athlete sprinting as fast as possible against a variety of loads, or really, how does load affect an athlete's velocity? And the one underpinning assumption of all of this is for every sprint your athletes do, that they do reach their fastest velocity at that load. So with this in mind, we have to pick the correct combination of loads and distances per sprint to ensure that they are long enough to where the athlete can actually achieve the fastest velocity, but not too long to where they're accumulating too much fatigue that could affect their sprints later on in the profile. My process for doing so, no matter if it is with equipment like a 1080 Sprint or simply just timing lasers and sleds or chains, is picking your longest, lightest sprint first, picking your heaviest, shortest sprint second, and then for your middle sprint, just bridging the gap in between those two. So with the 1080 Sprint, my first light sprint is going to be 2 kilograms. My last heavy sprint is going to be 20 kilograms. So something in the middle that's nice and square is 10 kilograms for my medium sprint. So now to pick distances that complement those loads that ensure that they do hit their max velocity, but they don't accumulate unnecessary fatigue. So 2 kilograms at 30 yards is my light long sprint. We have 20 kilograms at 20 yards for my heavy sprint, and we have our 10 kilograms 25 yards as in the middle of both of those. And this is the same process with timing lasers. So set up your lasers for your 5 yards of measured distance for the athlete's velocity, and then work your way backwards for the lead in distance. I'm fortunate enough to where I've coached with a 1080 Sprint for most of my career and haven't messed with sleds too much, so I would lean into you being the expert in sled sprints in your facility with your athletes, whatever you would consider light, medium, and heavy. Now, before we get into the Excel, this is a skill and a process just like anything else. So the more load velocity profiles you do, the better you will get at picking loads for certain athletes, adjusting the lead-in distances for the sprints to where you ensure that the athlete hits their max velocity with each sprint and each load every single time. And you should have 3 loads and 3 velocities for us to dive into Excel to calculate everything we need to calculate. Here we are to calculate our load velocity profiles, but first, let's dive into a little bit of the math, the why, because that is going to make calculating these formulas and actually writing them in Excel that much easier. So with a load velocity profile, all it is y equals mx plus b, and we know what all these variables are just by looking at this graph. So a load velocity profile, how load affects an athlete's velocity. So our x, our independent variable, the things that we control, that's load. How heavy do we make the sled when training, right? And velocity is on the y. So when load is something, how does that affect the velocity? Then next is b, y equals mx plus b. B is the intercept or the athlete's max velocity, or when the load is 0, how fast can the athlete go, right? Max velocity. So slope is just this line that connects all of the data points, or tries to at least. It's a straight line. So with that being said, y equals mx plus b, we can just rewrite as the velocity the athlete is running at is equal to the slope times the load plus their max velocity. So if we know that we want to run at certain velocity decrements in training, we know their velocity, then all we have to do is just work backwards to solve what the load should be to achieve that velocity. And I'll show you here. How do we just get load by itself? And this is basically just subtraction and division. So first, we have to subtract max velocity from each side. So I'll just rewrite this. Velo minus max velocity is slope times load. Again, this is y equals mx plus b. I'm just rearranging stuff. So next, to get load by itself, we just have to divide everything by the slope. So then I'll rewrite this again. Load equals velo that they're running at minus their max velocity divided by the slope. So this is the foundation, okay? Velo minus max velocity divided by the slope. And all of these things we know or we can calculate. The velocity decrement velocity, okay, I know that's kind of a tongue twister, but basically let's say an athlete's best is 10 miles an hour. That is their max velocity. And I want them to run 10% slower, then I want them to run at, say it with me, 9 miles an hour, right? So 10 minus 1. So their max velocity minus their max velocity times the percent that you want. So to put this all together, all we're doing is writing formulas that do this for us. And really, we have to write one formula once if we set up our Excel sheet as efficiently as possible. And all we're doing is this, okay? So the velocity they will be running at that velocity decrement, minus their max V divided by the slope. And then it'll tell us what load to pick to achieve that, all right? So now let's hop into Excel. All right, so name, your boy. We'll go today. The first load, we did 2 kilos, and then we did 10 kilos, and then we did 20 kilos, all right? The first velocity I achieved, let's say 20.1 miles an hour, because I'm just super fast like that. We'll go kind of 5 miles per hour-ish, slower. Let's go like 15.5. And then we'll go a little bit bigger drop. Let's go like 9.9 miles an hour, okay? And it is important to set it up all of the loads first and then all of the velocities first, and we'll see right here. So Excel is super nice because it has this built in for us. So slope, parenthesis. So known y's is first. And again, this is why we have to understand theoretically what the load velocity profile is. So our y's are going to be our velocity, okay? So let's just select, click, and drag over all of our 3 y's, comma, and all of our known x's. That's going to be all of our loads, all right? Boom, there's our slope. Already changed it to just give me like 2 or 3 decimal places. That's fine. So our intercept slash, we can just call that max V. So our intercept slash max V. Again, Excel is super nice. Intercept, it already has it for us. Our known y's again, so we're going to select all of the velos, comma, and we're going to select all of the y's, comma. And the reason why that's important to do it the right way is it knows that velo 1 is with load 1 and velo 2 is with load 2, okay? Hit enter. Again, I already removed some of the decimal places, and this is a good step to kind of guess and check your work. So 2 kilos is very light, so you would assume that instead of 2 kilos when it's 0, or the intercept or the max velocity would be a little bit higher, okay? So 2 kilos, I got 20.1 miles an hour. And with 0 kilos, I would get 21.2. So that makes sense to me, okay? So the R squared, so all it is, again, another formula that Excel has for us. Correl for correlation. Array 1 and array 2. It doesn't matter if you do the X's or the Y's first, but just to keep it consistent, let's highlight all of the Y's, comma, highlight all of the X's, comma. Enter. Oh, that's actually pretty good. So, actually that is perfect. But we have to square this. So let's go a parenthesis at the beginning, a parenthesis at the end, a little caret, and then a 2. So if you see up here in the formula bar, okay? Hit enter. But let's just change one of our velocities to make this profile a little bit less ideal. So let's go 1.1. All right. So again, a very good profile. Okay. So now, because these numbers are technically a percent, okay, if we come up here, then we have to make one formula once, and we can drag and drop it to wherever, and it'll calculate what we want it to calculate. So all we're doing is making a formula in Excel that does this, okay? So VDEC velo is basically this, and then our max V is our intercept, and then our slope we already calculated. So first, we need our VDEC velocity, okay? So first, enters. I need my max velocity minus our max velocity times the decrement. So also, we can quickly double check our work as we go. So if an athlete is running at a 10% velocity decrement, they're running at 90% of their max velocity. So we can just pull up a calculator right here. So we can just multiply 20.9 times 0.9, or they're running at 90% of their velocity, and that's 18.8, and then perfect. So we got the first part. So this is the velocity we want our athletes to run at, okay? So we have our velocity we want our athletes to run at. So we have to subtract the max velocity again. So let's add another set of brackets on each side because this is its own standalone calculation, okay? Minus the max velocity, okay? So the last thing we got to do is we just got to divide it all by our slope, okay? So let's put another round of brackets around it, and then divide it by, and then we can click on our slope, okay? Again, we can double check our work. So if 2 kilos gets us to 20 miles an hour-ish, and I know that this is supposed to be around 18-ish, then it should be a little bit heavier than 2. And we got 4 kilos, so that makes sense to me. So the last thing we got to do, because this formula is the same formula we will use for everything, but if we just copy and paste it down or over, everything moves over, right? Instead of the slope and the intercept, it's going to do the intercept and the r squared, okay? So what we do is our money signs are going to be our best friend. So if we click through this formula, so J2 is our max V. I always want this to be in the J column no matter what, but it can go down if we have, more athletes, right? If we have athlete 2, 3, 4, 5, 6. So I want the 2 to change, that is the column, but I want the J to stay the same. So you select the first J2, F4 on your keyboard. So we're going to hit F4. There's these double money signs. We're going to hit it again, and we're going to hit it again. So J is always going to stay the same no matter if I move my formula left or right, but the 2 will go up and down. Okay, so that's what the money sign means. So the same thing for J2. I'm going to hit F4, F4, F4. So now L1 is the velocity decrement. So I always want this to be in the first row because that's where my 10%, 25%, and 50% is. But I want this to go left to right. I want this to go from L to M to N, okay? So I'm gonna hit F4, F4. So it's always gonna stay in column 1, it's always gonna stay in row 1. So if I drag this down, it won't go down with it, but if I move this left and right, it'll move left and right because there's no money sign in front of the L, okay? So J2 again, I want the money sign just for the J. And then our slope, I2, is going to be the same thing because I want the I to stay the same, but if it goes up and down, then that's fine. So we're going to hit F4, F4, F4. Let's hit enter, and let's see if we did it right. So if we copy and paste this over, again, the velocity decrement stayed with it, but this stayed the slope and this stayed the max V, okay? So let's copy and paste it one more time. This is another good way to double check your work. The load to get 50% velocity decrement should be twice as much as 25. That's just how math works. So again, if we multiply 10.5 times 2, you get 21. And we can guess and check our work or double check our work. Let's go athlete 2. Let's say it was a testing day, so it was another, they did the same thing, 2:10, but they're nowhere near as fast as me. So let's go 18:5, but they're a little bit stronger. So let's go like 18:5. Let's go like 16:3. Let's go like 12:6. Okay, we can copy and paste all of this. So we can highlight all of this. We can paste it, and there we go. You have to make all these formulas once, and that is it. So as we saw here, the velocity decrement number is staying with the VDEX, but the slope and the max V kind of went down with it. So now all you have to do is type in this stuff, name, date, loads, velocities, and then copy and paste these formulas you already made. And then I would train at 4.2, athlete would train at 5.9 if we wanted a 10% velocity decrement. So that is how you calculate velocity decrements in Excel.